Alright, so we're going to build off of finding the inverse of a graph, and we're going to find the inverse from an equation, and it is always the same process. We're going to flip x and y and solve it for y. So it's very similar to the second method I showed you graphing, where we flip the x and y coordinates. Now we're going to flip the x's and y's completely. So we would say instead of f of x, that's like a y, we're going to say x equals negative 4y plus 7, and then just get y by itself. So we'll add, or subtract 7, I'm sorry, negative 4y, and divide by negative 4. So x minus 7 over negative 4 would be your inverse. Then the second one, we'll flip x and y, so 8x minus 2 is 3y plus 1. Solve for y, and you can do this in the same step. You don't have to take different steps. So we'll subtract 1, divide by 3. So 8x minus 3 over 3 would be your inverse. And then if we want to go back and find the domain and range, these aren't the best examples because they're just linear equations. So the domain and the range of the original, or f of x I should say, is all reals, negative infinity to infinity, negative infinity to infinity. When you're finding the domain and range of the inverse, it's pretty cool, because if you think about what happened in your equation, so my original, we had my x's and y's, I found my domain and range. We flipped x and y, and that's how we got my inverse. So the domain and the range are basically the reverse of the original. So the domain was dealing with x's, that's now the range of the inverse. The range was dealing with y's, that's now the domain of the inverse. So let me make another example real quick. Let's say my original function had a domain of negative 3 to infinity, and my range was negative infinity to infinity. I'm just making these up. The inverse would have a domain of negative infinity to infinity because that's the old range, and the range would now be negative 3 to infinity because that was the domain.